to a fascinating concept in graph theory, the Hamiltonian cycle. So, what exactly is a Hamiltonian cycle? Simply put, it's a path in an undirected or directed graph that visits each vertex exactly once and returns to the starting vertex. Think of it as a complete tour of all the locations in a network, ending up right back where you... Here, you can see an example. The highlighted edges form a cycle that passes through every single point, or vertex, in the graph exactly one time before closing the loop. Let's briefly touch upon a related idea, the Hamiltonian path. A Hamiltonian path visits each vertex exactly once, but it doesn't necessarily return to the starting vertex. So, it's like a tour that covers all locations but doesn't complete a full circle. You can see in this example, the highlighted path visits every vertex once, but the final vertex is different from the starting one. Algorithms, using rules of thumb to find a good enough solution in a reasonable amount of time, although these don't guarantee finding a Hamiltonian cycle if one exists. Why the Hamiltonian cycle important? It has several real-world applications, including 1. The traveling salesperson problem, TSP. 2. Route planning and logistics. 3. Network design. 4. Genome sequencing. Conclusion, the Hamiltonian cycle is a fundamental concept in graph theory that describes a complete tour visiting every vertex exactly once and returning to the start. While finding such cycles in general graph is computationally challenging, its applications in various fields highlight its significance. Thank you for your time.